The next video is about rational functions from 3.5. So you will need to know how to find all the asymptotes. We have three types of asymptotes. So if you need to pause the video and write down, please do that, including vertical asymptotes, horizontal asymptote, and then slant asymptote. Alright, so vertical asymptote basically is finding which part the graph cannot touch for the x values. It's an invisible vertical line that the graph cannot touch. So to find that is pretty much the same as finding the domain. We are going to set the denominator equal to 0. So this one have an x minus 5 as denominator, and we look at this first. Like normally we want to check and see if we can factor, and then if there's anything we can reduce. So for this particular one, multiply to be -4, the difference is 1, so I don't think that can be factored, so there's nothing we can reduce about. So setting the denominator x minus 5 equal to 0 and solve for x. Sometimes students will tell me the answer is 5, and that's not a proper way of writing a vertical asymptote. Vertical asymptote is a vertical line, so make sure you write as x equal to 5, because vertical asymptote has to be x equal to some number to represent a vertical line, okay? So this is a vertical asymptote. For horizontal asymptote, it may come in many different types, but in general, what we want to do is say y equal to some number, and it's going to be y equal to whatever the leading coefficient on top over the leading coefficient at the bottom. So we can look at this one. Look like the highest power is square. So I'm going to say y equal to 4x squared is the leading coefficient of 4. And then I don't have an x squared at the bottom, so I'm going to force them in to have an x squared. But it doesn't exist, so I don't want to change the question, so I'm going to need to multiply a 0 there. So I'm going to pick up this part. And if you move on to calculus, you will learn about limits and why the other term will be gone as x become a bigger and bigger number. Okay, so let's see. This means y is 4 out of 0. We cannot have 0 for denominator, or we cannot have 4 out of nothing. So this is undefined. If you have an undefined horizontal asymptote, it means you have no horizontal asymptote. Alright. Okay, slant asymptote. So in some situation we have slant asymptote, and slant asymptote only occurred when the top is exactly 1 degree higher than the bottom. So when that happens, you have slant asymptote, and you know if the top is higher, you don't have horizontal, right? So you cannot have both at the same time. To find slant asymptote, what we will do is we will use division, and the answer for slant asymptote is going to set y equal to quotient. So for this one, we will ignore the remainder, so for slant asymptote. So let's look at this one. Does it have a slant asymptote? Is the top exactly 1 degree higher than the bottom? It looks like it is. And it also looks like I can do synthetic division for this one. Yay! Let's do it. Okay, so what do I put here? It's using the divisor and solve for x, right? So x equal to 5. 5 go here, and then we write down the coefficient for the dividend here, which we have 4, -1, -1, right? So we bring down the 4 times 5 is 20. Together we got 19 times 5 is going to be a big number, 95. Combine that, we have 94. So the last number is remainder, and we say we ignore that, right? And then the slant asymptote supposed to be set y equal to quotient. So y equal to is from a degree 2 divided by degree 1, so it dropped 1, so this would be 4x to the first power plus a 19. So that would be a slant asymptote. So please practice the asymptote. I don't want you to leave this blank on the test. Vertical asymptote set denominator equal to 0. The answer has to be x equal to a number. Horizontal asymptote, the answer would be y equal to a number, and basically compare the leading coefficient top and bottom, set equal to y. Slant asymptote only occurs when top is 1 degree higher than the bottom. And then we need to use division. Sometimes we may need to use long divisions. The answer for slant asymptote would be setting y equal to quotient. All right? Okay, so one more question for 3.5. So the next one, we have another rational function, a basic one. We're going to need to graph it using intercept and asymptote. So that's the two things you need for graphing rational function. And then we also know rational function is a function, meaning it has to pass the vertical line test, and your graph is going to get very close to those asymptotes, right? Asymptote is going to help you to decide the end behavior of your graph. So we're going to need x and y intercept. And then we're going to need all those asymptotes, right? Horizontal, vertical. If it has horizontal, it's not going to have slant. If it has slant, it's not going to have horizontal, right? X-intercept, we're going to set y equal to 0. Y-intercept, we're going to set x equal to 0. Vertical asymptote, we just talked about it, right? Set denominator equal to 0. Horizontal asymptote is going to be y equal to the leading coefficient on top over leading coefficient at the bottom. Slant asymptote, you only have it if the top is 1 degree higher than the bottom part. And then you divide and you set y equal to quotient. So looking at this particular question, I don't see the top is 1 degree higher than the bottom. I can automatically tell you that for the slant asymptote, it's going to be none, right? But those are the main points you probably need to study: how to find x-intercept, y-intercept, vertical asymptote, horizontal asymptote, and slant asymptote. All right, not the none part. All right, so set y equal to 0. Let's see. We got 3x minus 1, x minus 1 here equal to 0. So to solve for x, we really want to get rid of the denominator. You can get rid of the denominator by multiplying the LCD to both sides to try to cancel the denominator. And 0 times the denominator is still going to be 0, right? And then we have 0 equal to 3x minus 1. Then we will try to solve for x, right? So add 1 both sides, 1 equal to 3x. Divide both sides by 3. So x equal to 1/3. If that's my x-intercept, it means x equal to 1/3, y equal to 0, right? So we got the x-intercept. For the y-intercept, we're going to need to set x equal to 0. So we're going to have y equal to 3 times 0 minus 1, 0 minus 1, right? X equal to 0. So after you simplify that, we get y equal to negative 1 over negative 1. So y basically is positive 1. So if that's your y-intercept, when I y the points, it's going to be x equal to 0, y equal to 1, right? So that's another intercept. So for the vertical asymptote, I need to set my denominator x minus 1 equal to 0. So again, the answer should be x equal to a number, right? So x equal to 1 is my vertical asymptote. Horizontal asymptote, this time we have matching x to the first power, right, as the highest power. So I'm going to say y equal to 3x over 1x, right? So I just pick up the leading coefficient equal to y. So I can see my horizontal asymptote is y equal to positive 3, right? So I have vertical, horizontal, I don't have slant. I think I'm ready to graph. So I'm going to need to put my asymptote and the intercept on the graph. We got vertical asymptote x equal to 1. If I have one vertical asymptote, it divides into two sections, right? It means I'm going to end up with two pieces of graph. Okay, and then horizontal asymptote is y equal to 3, 1, 2, 3, which means I can either have a curve up here or down here. I cannot have both, because if I have both of these, it will not pass the vertical line test and it's not a function. On the left-hand side, I can either have the top piece or the bottom piece, but I cannot have both because it has to stay as a function that passes vertical line test. So beside the vertical and horizontal asymptote, I also have my intercept. My intercept say y equal to 1. I need to go through this point and x equal to 1/3. So 1/3 about here. So obviously, if I need to pick top or bottom, I can see this going to be the bottom part because I have to go through my intercept, right? And the ends should get close to the asymptote but not touching it. On this side, if you want to, you can test the point. And sometimes you will have to test points. This is x equal to 1, so if you test an x equal to 2, it would find the value over here. Plug it to the original function, y equal to 3 times 2 minus 1, and then 3 minus 1, right? So 3 times 2 is 6, minus 1, 3 minus 1 is 2, so this is like 5 over 2, which is like a 2.5. Is that right? Okay, hold on. X equal to 2, so it's a 2, sorry about that. X equal to 2, so it's 3 times 2 here minus 1, and the bottom is 2 minus 1. My mistake. So this would end up with a 1 here and a 1 here. So 5 divided by 1, y equal to 5. So when x equal to 2, your y value should be 5. So 1, 2, 3, 4, 5. So it means like somewhere here. So hopefully you will find it over here, close to the asymptote. Like I already know it's on top, even though I didn't plug in the point, and actually I almost did it wrong, so be careful with that. Because I only have one x-intercept here, right? Which is x equal to 1/3, and then I don't have another x-intercept here, which kind of tell me the graph is never going to touch this side, so it has to be on the top. So again, because it only have one x-intercept, so it already caused it here, and there's no other x-intercept here, so automatically I kind of know it's on the top. And if you try to plug in point, like, you have to be more careful than I did earlier, so you will get the y correct value. So that's it for 3.5. Thank you.